Hi everyone, how are you? Today we discuss about integration problems. Okay, now explain integral dx by secant x plus tan x plus cosecant x plus cot x. How can solve this problem? Integral dx by, we know that secant x formula is 1 by cos x, tan x is sin x by cos x. If we have cosecant x formula is 1 by sin x, we know that cot x is cos x by sin x. Here, so what is LCM here? Integral dx by, so LCM is cos x into sin x. After taking LCM, what we get here? Here sin x, here into sin x into sin x. This is sin square x. So this is cos x. Here cos square x. So after that integral. So this denominator multiply with dx. What we get here? Cos x sin x dx by. Because we have sin square x plus cos square x is 1. 1 plus cos x plus sin x. So here divide multiplied by 2. What we get? 1 by 2 times of 2 cos x sin x. We know that sin 2x upon 1 plus cos x plus sin x. Okay. We know that sin 2x, one more formula, sin 2x is equal to cos x plus sin x plus 1 into cos x plus sin x minus 1. So after simplification, we get sin 2x. Let us take cos x plus sin x is A, 1 is B. We know that A plus B into A minus B, A square minus B square, cos x plus sin x whole square, A square. It is cos x plus sin x whole square minus B square is 1. According to A plus B whole square formula, cos square x plus sin square x plus 2 sin x cos x, 2ab minus 1. Here cos square plus sin square x, here 1 cancel. So what we get here, 2 sin x cos x is nothing but sin 2x. Where sin 2x, we can write cos x plus sin x plus 1 into cos x plus sin x minus 1. Now, so what is their previous step? 1 by 2 times of sin 2x dx by cos x plus sin x plus 1. So 1 by 2 times of, so we know that sin 2x is cos x plus sin x plus 1 into cos x plus sin x minus 1 upon cos x plus sin x plus 1 dx. Here 1 cos x plus sin x plus 1, 1 cos x plus sin x plus 1 get cancelled. What we get here? 1 by 2 times of integral cos x dx. Now applying integration to each function, integration of sin x dx minus integration of 1 dx. Okay, we get answer 1 by 2 times of integration of cos x is sin x, integration of sin x is minus cos x, the minus 1 dx value minus x plus c. This is answer. Okay, next I am going to explain integral x to the power 5 plus x to the power 4 plus 4x cube plus 4x square plus 4x plus 4 dx by x square plus 2 whole cube. Okay, x to the power 4 plus x to the power 5 plus x to the power 4 plus 4x cube plus 4x square plus 4x plus 4 can be written as x square plus 2 whole square into x plus 1. Why? Because here minus 1 is one of the factor of this expression. So we get the integral x square plus 2 whole square into x plus 1 dx by, what is denominator here? X plus 2, x square plus 2 whole cube. 1 x square plus 2 whole square get cancelled. So what we get here? X plus 1 dx by x square plus 2. Okay, now do individual division. X dx by x square plus 2 plus 1 dx by x square plus 2. So here first integral, let us take x square plus 2 is equal to t. Why? Because this derivative here, there, dt by 2. What is derivative? 2x dx is equal to dt. We get dx is equal to dt by 2. The differentiation of x square to x, differentiation of 2 is 0. Okay, now this continuation. Therefore, integral x dx by x square plus 2 plus, what is there here? Second integral 1 dx by x square plus 2. The 2 place we should write root 2 whole square. Okay, here if denominator is t, the numerator will be dt by 2. So dt by 2 times of t. Here we have one formula, integral dx by x square plus a square. What is the formula? 1 by a tan inverse of x by a plus c. So 1 by root 2. In the place of a, here what is there? Root 2 is there. 1 by root 2 tan inverse of x by root 2 plus c. Now here 1 by 2 constant. Integral dt by t, we get log t. Why? Because derivative of log t is 1 by t. Integration of 1 by t is log t. So 1 by root 2 times of tan inverse of x by root 2 plus c. So 1 by 2 times of log of, in the place of t, we have assumed x square plus 2. So 1 by root 2 tan inverse of x by root 2 plus c, done. Let us go to the next problem. Integral dx by cos to the power 6x plus sin to the power 6x. Integral dx by cos to the power 6x can be written as cos square x whole cube plus sin to the power 6x plus in right sin square x whole cube. Okay, we know that a cube plus b cube. A cube plus b cube formula, a plus b into a square plus b square minus ab. So in this formula, a place in, we should write cos square x, b place in sin square x. What we get here? Cos square x whole cube sin square x whole cube. We get a place in cos square x, b place in sin square x. In right side, a plus b, we get a is cos square x, b is sin square x, cos square x plus sin square x, we get 1. Now a square value, already a value cos square x, a square is cos to the power 4x. Here b square, we get sin square whole square is sin to the power 4x minus ab, minus cos square x into sin square x. So integral dx by, in whole denominator relation we should write this value, cos to the power 4x plus sine to the power 4x minus cos square x into sine square x. Okay, here this kind of problems, we should divide cos to the power 4x or sine to the power 4x on numerator as well as denominator. Divide cos to the power 4x or sine to the power 4 on numerator as well as denominator. So what we get here? Integral dx by cos to the power 4x by, here cos to the power 4 by cos to the power 4 value 1, sine to the power 4 by cos to the power 4 we get tan to the power 4x, cos square x sine square x by cos to the power 4. Cos to the power 4 means cos square x into cos square x. Here cos square x cancel. What we get here? Integral 1 by cos to the power 4 is nothing but secant to the power 4x dx by 1 plus tan to the power 4x. So sine square by cos square we get tan square x. So let us take tan x is equal to t here. Then secant square x dx value dt. Integral. So secant to the power 4 place in right, secant square x into secant square x upon, here denominator what is there? 1 plus tan to the power 4 minus tan square x. Here we have secant square x one formula, trigonometric formula 1 plus tan square x. So we should write secant square x place in right 1 plus tan square x. Now let us take tan x is equal to t. Then secant square, now differentiation on both the differentiation of tan x, we get secant square x dx is equal to dt. Therefore, integral 1 plus, in the place of tan x, we should write t square. Secant square x dx is, we have got dt by 1 plus t to the power 4. In the place of tan x, we should write t square here. Okay, this kind of problems, they here one t square you should take common on numerator as well as denominator. T square I take common 1 plus 1 by t square. In denominator I take t square common. What we get here? 1 by t square plus t square minus 1. Here 1 t square get cancelled. What we get here? Integral. Here this kind of model, you will take t minus 1 by t is equal to y. Why? Because this derivative here there on numerator. So differentiation on both sides. Differentiation of t we get 1. Differentiation of minus 1 by t plus 1 by t squared. Dt is equal to dy. So integral 1 plus 1 by t squared dt is dy. Dy by, first find out 1 by t squared plus t square value here. How can find? Here we have assumed t minus 1 by t is equal to y. Now squaring on both sides, what we get here? T square, a minus, according to a minus b whole square, a square plus b square minus 2ab. Minus 2ab minus 2 into t into 1 by t is equal to y square. So t square plus 1 by t square value minus 2 sending other side, we get t square plus 1 by t square is equal to y square plus 2. So what is the statement here? Integral 1 plus 1 by t square dt by t 1 by t square plus t square minus 1. Okay. If t plus t minus 1 by t is equal to y, then numerator will be dy by here t 1 by t square plus t square, we have got y square plus 2. Y square plus 2 minus 1. What we get here? Dy by plus 2 minus 1 is y square plus 1. Okay, we have formula tan inverse of y. So tan inverse of, in the place of y, we should write t minus 1 by t. T minus 1 by t. What is the t here? T only we have assumed tan x. Therefore, final answer is tan inverse of t for tan x. 1 by tan x is cot x. So tan x minus cot x plus the answer. Okay, now let us go to the next problem. Integral n to n plus 1 f of n dn is equal to n square plus n. Then find out integral minus 1 to plus 1 f of x dx. So what is required here? Minus 1 to plus 1 f of x dx. So this integration can be written as integral minus 1 to 0 f of x dx plus integral 0 to 1 f of x dx. But from statement, what is given here? Integral n to n plus 1 f of n dn is equal to n square plus n. But here let us observe here n is, now we should apply this property, this condition. Here n is equal to minus 1. So 0 can be written as n plus 1 combination. Here minus 1 to, so 0 place we should write minus 1 plus 1 f of x dx plus here n value 0 in this second integral part. Here one place we should write 0 plus 1 f of x dx. So according to condition, here in first integral value, here n value how much value? Minus 1. This is n plus 1. Here n value how much value? 0. Here upper limit is n plus 1. So what is the given condition? Integral n to n plus 1 f of n dn is n square plus n. In this condition, in the place of n, first we should write minus 1. So minus 1 whole square plus minus 1. Plus here in second integral place in n place we should write 0. So 0 square plus 0. What we get here? So minus 1 whole square is plus 1, minus 1, it will be 0. The answer will be 0. Okay, let us go to the next problem. Integral minus pi by 2 plus pi by 2 e to the power sin square x into sin to the power 2n plus 1x. Here, by using property number 3, here this is e to the power sin square x is even function. Sin to the power 2n plus 1x is odd function. So integration of odd function, it will be 0. This answer will be 0. Okay, now explain this proof. By using this property on replacing x by lower limit plus upper limit minus x. What is the property number 3? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. In the place of x, we should write lower limit plus upper limit minus x. What is the lower limit here? Minus pi by 2. What is the upper limit? Pi by 2 minus x. It will going to be minus x. Okay, here in the place of x, we should write minus x. E to the power sin square minus x into sin minus x to the power 2n plus 1 dx. But sin of minus x value how much? Minus sin x power odd number. It will going to be minus power odd number is equal to minus negative. So minus pi by 2 to plus pi by 2. E to the power sin square of minus x is plus sin square x into sin x to the power 2n plus 1 dx. Okay, this is nothing but I. So I is equal minus I sending left side. What we get 2I is equal 0. I we get 0. This answer also will be 0. Let us go to the next problem. If a less than 0 less than b, that implies integral a to b modulus of x dx by x is. How can find this problem? So from a to b, between here 0 given. So here one integration can be expressed as sum of two or more integral. So by using that property, a to b modulus of x dx by x. Here I can write integral a to 0 modulus of x by x into dx plus 0 to a, 0 to b modulus of x by x into dx. So a to 0, from a to 0 modulus of x value from 0 to a modulus of x is equal to minus x. Why? Because a to 0 modulus of x less than 0 modulus of x is minus x. From 0 to b, from 0 to b, modulus of x we should take plus x. Okay, here a to 0 modulus of expression, right, minus x by x dx. From 0 to b, more than 0 modulus of x is plus x by dx. Here x get cancelled. Minus integration of minus dx is minus x from limits 0 to a. Here 1 dx is x from limits b to 0. What we get here? Minus constant. First write on replacing x by upper limit minus lower limit. Here expression right upper limit minus lower limit. What we get here? Plus a plus b. A plus b answer. Okay, now let us go to the next problem. Integral n to n plus 1 f of n dn is equal to n square plus n. Then find out integral minus 1 to plus 1 f of x dx. So what is required here? Minus 1 to plus 1 f of x dx. So this integration can be written as integral minus 1 to 0 f of x dx plus integral 0 to 1 f of x dx. But from statement, what is given here? Integral n to n plus 1 f of n dn is equal to n square plus n. But here let us observe here n is, now we should apply this property, this condition. Here n is equal to minus 1. So 0 can be written as n plus 1 combination. Here minus 1 to, so 0 place we should write minus 1 plus 1 f of x dx plus here n value 0 in this second integral part. Here one place we should write 0 plus 1 f of x dx. So according to condition, here in first integral value Here n value how much value? -1. This is n plus 1. Here n value how much value? 0. Here upper limit is n plus 1. So what is the given condition? Integral n to n plus 1 f of n dn is n square plus n. In this condition, in the place of n, first we should write -1. So -1 whole square plus -1. Plus here in second integral place in we should write 0. So 0 square plus 0. What we get here? So -1 whole square is +1, -1 it will be 0. The answer will be 0. Okay, let us go to the next problem. Integral -π/2 plus π/2 e to the power sin square x into sin to the power 2n plus 1x. Here, by using property number 3, here this is e to the power sin square x is even function. Sin to the power 2n plus 1x is odd function. So integration of odd function, it will be 0. This answer will be 0. Okay, now explain this proof. By using this property on replacing x by lower limit plus upper limit minus x. What is the property number 3? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. In the place of x, we should write lower limit plus upper limit minus x. What is the lower limit here? -π/2. What is the upper limit? π/2 minus x. It will going to be minus x. Okay, here in the place of x, we should write minus x. E to the power sin square minus x into sin minus x to the power 2n plus 1 dx. But sin of minus x value how much? Minus sin x power odd number. It will going to be minus power odd number is equal to minus negative. So minus π/2 to plus π/2. E to the power sin square of minus x is plus sin square x into sin x to the power 2n plus 1 dx. Okay, this is nothing but I. So I is equal minus I sending left side. What we get 2i is equal 0. I we get 0. This answer also will be 0. Let us go to the next problem. If a less than 0 less than b, that implies integral a to b modulus of x dx by x is. How can find this problem? So from a to b, between here 0 given. So here one integration can be expressed as sum of two or more integral. So by using that property, a to b modulus of x dx by x. Here I can write integral a to 0 modulus of x by x into dx plus 0 to a, 0 to b modulus of x by x into dx. So a to 0, from a to 0 modulus of x value from 0 to a modulus of x is equal to minus x. Why? Because a to 0 modulus of x less than 0 modulus of x is minus x. From 0 to b modulus of x we should take plus x. Okay, here a to 0 modulus of expression, right, minus x by x dx. From 0 to b more than 0, modulus of x is plus x by dx. Here x get cancelled, minus integration of minus dx is minus x from limits 0 to a. Here 1 dx is x from limits b to 0. What we get here, minus constant, first write on replacing x by upper limit minus lower limit. Here x place in right upper limit minus lower limit. What we get here, plus a plus b. A plus b answer. Well, let us go to the next problem. Here I is equal to integral 0 to 1 root under 1 plus x cube dx given. The options, first option I greater than 1, I greater than root 5 by 2. Third option I greater than root 7 by 2. Fourth option I less than 1. How can solve this problem? Between 0 to 1, here x value lies between 0 to 1. Okay, now this condition make into root 1 plus x cube combination. Now cubing on both sides, what we get? Cubing on both sides. 0 less than x cube less than 1 cube. Well, now here plus 1 is there, add 1 on both sides. So 1 less than 1 plus x cube less than 2. Now here what their state from statement, root is there. Now square root on both sides. Root 1 less than root under 1 plus x cube less than root 2. Okay, now we should take this condition. So 1, root 1 is nothing but 1 less than root under 1 plus x cube. Now taking integration. Now taking integration from 0 to 1 limits. So what we get here? Integral 0 to 1 dx less than integral 0 to 1 root under 1 plus x cube dx. Integral 1 dx we get x from limits 1 to 0 less than, this is nothing but statement I. Therefore what we get, left side 1 minus 0 is 1 less than I, is nothing but I greater than 1. Option 1 is correct. Okay, moving to next question. In the statement k less than or equal to integral 0 to 2 pi dx by 5 plus 4 cos x less than or equal to L given, then find out closed interval k comma L. Well, let us observe here cos x function lies between -1 to +1. Here cos x range is -1 to +1. Let us take this range interval. Okay, what is here cos x is lies between -1 to +1. First this function make into denominator function. Denominator what is there here? 5 plus 4 cos x. So before cos x before, here 4 number is there. Now multiply 4 on both sides. So minus 4 less than or equal to 4 cos x less than or equal to 4. After that, we should observe in denominator 5 plus is there. Add 5 on both sides. 5 minus 4 less than or equal to 5 plus 4 cos x less than or equal to 5 plus 4. What we get here? 1 less than or equal to 5 plus 4 cos x less than or equal to 9. But in statement 1 by 5 plus 4 cos x here there. Now taking reciprocal 1 by 1, the less than or equal to change into greater than or equal to 1 by 5 plus 4 cos x. Here less than or equal place and write greater than or equal to by is 1 by 9. Here, what is the minimum value? Here, minimum value is 1 by 9. Here, maximum value is 1. Okay, write this reverse order 1 by 9 less than or equal to 1 by 5 plus 4 cos x less than or equal to 1. Okay, now we should observe in statement. In statement, integral 0 to 2 pi intervals are there. Now taking integration from 0 to 2 pi intervals. Integral 0 to 2 pi 1 by 9 dx less than or equal to integral 0 to 2 pi dx by 5 plus 4 cos x less than or equal to integral 0 to 2 pi 1 dx. So here 1 by 9 constant, 1 by 9 times of, so 1 dx value how much x? From limits to 2 pi to 0 less than or equal to, is here middle value is statement. So the statement, that is a statement condition, less than or equal to 1 dx value how much x? From limits to 2 pi to 0. What we get here 1 by 9. So first write on replacing x by upper limit minus lower limit. 2 pi minus 0 is 2 pi less than or equal to, in the statement question what is there? Integral 0 to 2 pi dx by 5 plus 4 cos x less than or equal to, this value will be for 2 pi minus 0 is 2 pi. On comparing k less than or equal to integral 0 to 2 pi dx by 5 plus 4 cos x less than or equal to L, where KL values closure interval k comma L is equal to, what is the k value here? 2 pi by 9 is minimum value of this function. 2 pi is maximum value. So what is the answer here? 2 pi by 9 comma 2 pi. Okay, let us go to the next problem. Integral 1, 2, 3 dx by x square plus integral part of x whole square plus 1 minus 2x integral part of x. Okay, let us observe here x square integral part of x whole square minus 2x into integral part of x. What is the form? A square plus b square minus 2ab. I can write 1, 2, 3 dx by, this relation we should write x minus integral part of x whole square plus 1. Okay, here between 1 to 3 integer value is 2. So 1 to 2 dx by x minus integral part of x whole square plus 1 plus integral 2 to 3 dx by x minus integral part of x whole square plus 1. In between 1 to 2 integral part of x value how much? 1. In between 2 to 3 integral part of x value how much? 2. Why? Because you will take any number, any real number between 2 to 3, 2.8, 2.9, integral part of value is 2. Here also 1.1, 1.2, you will take any real number from 1 to 2, integral part of x value is 1. What we get here? Integral 1 to 2 dx by x minus 1 whole square plus 1 plus integral 2 to 3 dx by x minus 2 whole square plus 1. Okay, we have one formula, integral dx by x square plus x square plus 1 is equal to, what is the formula? Tan inverse of x. According to this formula, what we get here? In the place of x here, x minus 1, here x minus 2 there. Now we should apply the same formula, tan inverse of x minus 1 from limits 2 to 1. Here formula is tan inverse of x minus 2 from limits 3 to 2. Now write first on replacing x by right upper limit 2 minus 1, 1 minus tan inverse of, on replacing x by right lower limit 0, 1 minus 1, it will be 0. Here also write Tan inverse of on replacing x by 3, right? 3 minus 2, 1. On replacing x by lower limit, right? 2, 2 minus 2, 0. What we get tan inverse 1 is pi by 4. This value is 0, this value is 0. Tan inverse 1 value again, right? Pi by 4. Pi by 4 plus pi by 4, it will going to be pi by 2. What is the answer here? Pi by 2. Okay, moving to next question. Integral 2 minus root 3 to 2 plus root 3 dx by 1 plus x into 1 plus x square. How can solve here? 1 plus x square combination is there. Let us take x is equal to tan theta. Then dx we get derivative of tan theta, we get secant square theta d theta. Now change the lower limit as well as upper limit. If x is equal to 2 minus root 3, x is equal to 2 minus root 3, then find out theta value. Tan theta is equal to x, 2 minus root 3. So 2 minus root 3 tan in which degrees? Tan 15 degrees. So theta we get 15 degrees. If x value 2 minus root 3, in theta value 15 degrees. Okay, next write upper limit. What is upper limit here? If x is equal to 2 plus root 3, that implies tan theta is equal to x. X is equal to 2 plus root 3 is placed in that tan 2 plus root 3 is tan is nothing but tan 75 degrees. We get theta is equal to 75 degrees. Now substitute here only. So therefore I is equal integral 15 degrees to 75 degrees. X dx. X value how much? Tan theta already we have assumed. Dx value we have got secant square theta d theta upon 1 plus x. 1 plus x it will be 1 plus tan theta. Here 1 plus x square. 1 plus x square is nothing but 1 plus tan square theta. Here 1 plus tan square theta is nothing but secant square theta. Secant square theta get cancelled. After changing sine and cos, what we get here? Integral 15 degrees to 75 degrees. So tan theta, we have formula sine theta by cos theta. D theta by denominator place 1 plus tan theta place and right 1 plus sine theta by cos theta. So after taking LCM, what we get here? Cos theta get cancelled. Therefore, integral 15 degrees to 75 degrees. Sine theta d theta by. So after taking LCM, what we get here? Denominator cos theta plus sine theta. So this kind of problems we can multiply divide by 2 here. 1 by 2 times of integral 15 degrees to 75 degrees. 2 sine theta d theta by sine theta plus cos theta. Okay, what we get? 1 by 2 times of integral 15 degrees to 75 degrees. 2 sine theta d theta by sine theta plus cos theta. So 2 sine theta, I can write sine theta plus cos theta plus sine theta minus cos theta. Therefore, 1 by 2 times of integral 15 degrees to 75 degrees. Here 2 sine theta operation, I can write sine theta plus cos theta plus sine theta minus cos theta d theta. Do individual division here, denominator sine theta plus cos theta, here divide, here also divide. Now, here sine theta plus cos theta get cancelled. What we get here? 1 by 2 times of 1 d theta. 1 d theta, it will be theta limits 75 degrees to 15 degrees plus integral 15 degrees to 75 degrees sine theta minus cos theta d theta by sine theta plus cos theta. Here, let us take denominator is t. So denominator is f of x. Then numerator will be The derivative of sin theta is cos theta. Derivative of cos theta is minus sin theta. Okay. The denominator is f of x. Numerator will be minus f dash x. Okay, we have one form integral f dash x dx by f of x. We have formula is log f of x. According to this formula, write 1 by 2 times of 1 by 2 times of 1 by 2 times of here, write 75 minus 15, how much value? 60 degrees plus 1 by 2 times of here integral 15 degrees to 75 degrees. According to formula, direct write. So what is the direct formula? Integral f dash x dx by f of x. In this sin theta minus cos theta, you will take one minus 1 common. Minus sin theta plus cos theta into here minus. So direct write here. So denominator is f of x, numerator will be f dash x. So we have formula log of sin theta plus cos theta from limits 75 degrees to 15 degrees. So 1 by 2, 1 j, 2 30 j get cancelled. So 30 degrees is nothing but 5 by 6 minus. So this value will be 1 by 2 times of first theta place and right upper limit. What we get here? Log of sin 75 degrees plus cos 75 degrees minus log of here theta place and right lower limit 15 degrees plus log of cos log of sin 15 degrees plus cos 15 degrees. After using values sin 75 plus cos 75 log of sin 75 plus cos 75 minus log sin 15 plus cos 15 value, this value will be 0. Total value. The answer will be 5 by 6. So half log, so 1 by 2 times of log 75 plus cos 75 minus log of sin 15 plus cos 15 value will be 0. Okay, now explain this proof also. Since log of sin 75 degrees plus cos 75 degrees. So we have log a minus log b is log a by b. Sin 15 plus cos 15. The log of sin 75 degrees. How much value? This is for 30 plus 45, root 3 plus 1 by 2 root 2. This is root 3 minus 1 by 2 root 2. Here sin 15, 45 minus 30. Okay, root 3 minus 1 by 2 root 2. Here root 3 plus 1 by 2 root. All are get cancelled. The log 1 will be log 1 value 1. Log 1 value 0. Okay, let us go to the next problem. Integral 0 to pi by 2, 2012 sin to the power 2011x minus 2008 cos to the power 2011x by sin to the power 2011x plus cos to the power 2011x. So by using property number 3, property 3 or 4. So what is the property? On replace, this is the property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So on replacing x by lower limit plus upper limit minus x. What is the lower limit here? 0 plus a minus x, it will be a minus x. Here lower limit is 0, upper limit pi by 2 minus x. 0 plus pi by 2 minus x. So on replacing x by, we should write pi by 2 minus x. Okay, let us take statement is I.
So this is equation 1. So I is by using this property, what we get here, integral 0 to pi by 2, 2012 sine to the power 11 pi by 2 minus x, 2011 pi by 2 minus x minus 2008 cos to the power 2011 pi by 2 minus x dx by sine to the power 2011 pi by 2 minus x plus cos to the power 2011 pi by 2 minus x. Therefore, I is equal to integral 0 to pi by 2. So sin 90 minus x, we get cos x 2012 cos to the power 2011 x minus 2008 cos 90 minus x, we get sin 2000 sin to the power 2011 x dx by, what is the denominator here? Sin 90 minus x is cos to the power 2011 x plus sin to the power 2011 x. Okay, this is the second equation. Now adding equation 1 and equation 2, what we get here, I plus I 2i is equal to, let us observe here in two denominators here in equation 1, in equation 2, denominators are same, like fractions. What is LCM here? Integral 0 to pi by 2. So LCM is same. Sin to the power 2011x plus cos to the power 2011x. After taking LCM, in numerator here 2012 sin to the power 11x, here 2012 cos to the power 2011x. I take 2012 common. 2011 common. What we get here? 2000 here, direct subtraction here. Minus 2008 cos to the power 2011x. Here plus 2012 cos to the power 11x. Okay, direct adding. Adding means here 2012 minus 2008. How much value here? 4. Direct write 4. 4 times of cos to the power 2011x. Here 2012 sin to the power 11x. So here minus 2008 sin to the power 11. So here plus 4 sin to the power 11x. Here I take 4 common. Rest of value cos to the power 2011x. So sin to the power 2011x get cancelled. What we get here? 4 dx. Therefore, 2i is equal to integral 0 to pi by 2, 4 dx. So 4 into 1 dx value x limits to pi by 2 to 0. I we get 2 1 j 2 2 j get cancelled. 2 times of, so pi by 2 minus 0 is pi by 2. What we get here? Therefore, I is equal to 5. Answer is 5. Let us go to the next problem. Integral root under log 2 to root under log 3 x sin x square dx by sin x square plus sin of log 6 minus x square. So this kind of problems here, x square common value is there. Let us take x square is equal to t. Why? Because this derivative here there, dt by 2. Now derivative on both sides, 2x dx is equal to dt. X dx we get dt by 2. Okay, now change the lower and upper limits in terms of t. If x value root log 2, then t value how much? So x square. If x value, what is the root log 2? Root log 2 is lower limit of x, this function. Here this is upper limit of this function. So if x is equal to root log 2, then t is equal to x square is log 2. If x is equal to root log 3, then t is equal to x square. X square means root log 3 whole square is log 3. Okay, here sin x square place in right t, x dx value we have got dt by 2 upon sin t plus sin of log 6 minus t. In the place of x square, we should write t. This is the equation 1. So on by using property number 3, on replacing x by lower limit plus upper limit minus x, LL plus UL minus x. What is the lower limit here? Lower limit is log 2, upper limit is log 3 minus x. The log 2 plus log 3, we get log AB formula log 6 minus x. So in the place of here t place in right. Why? Because this function is t. So in the place of t, write log 6 minus t. Integral log 2 to log 3 sin. In the place of t, write log 6 minus t dt by sin of here 1 by 2 constant right outside. In the place of t, write log 6 minus t plus sin of. So log 6 minus t place in right t. This is equation 2. Now adding equation 1 and equation 2. Add equation 1 and equation 2. In equation 1, here 1 by 2, right outside. The statement is I. This is also I. So adding 1 and 2 equations, what we get here? I plus I, 2I is equal to. Here in equation 1, 1 by 2. In equation 2, 1 by 2. I take 1 by 2 common. 1 by 2 times of. What is there here? So here let us observe equation 1, equation 2. Denominator values also same. Like fractions. Okay, integral 0 to pi by 2. 0 to pi by 2. Root log 2 to log 3. Log 2 to log 3. So what is here denominator? Sin t plus sin of log 6 minus t. Sin t plus log sin of log 6 minus t. Here denominator is LCM. Numerator value here sin t, here sin of log 6 minus t, right? Sin t plus sin of log 6 minus t. Okay, here these two are same values get cancelled. What we get here 1 by 2 times of 1 dt. 1 dt is t limits log 3 to log 2. So 1 by 2 times of right on the place in the place of t, right first upper limit. After that lower limit. 2i is equal to 1 by 4 times of log a minus log b. We get log a by b log 3 by 2. So what we get answer 1 by 4 log 3 by 2. Thank you for watching. Remaining questions I will explain on coming videos.